Mars is dead, and it's not because there's no water there. There is water, locked away under the ground and ice, hidden from sight. Mars is dead because the sun is literally blowing its atmosphere away right now, in this very second, as you listen to these words. Solar wind, a stream of charged particles racing from the star at hundreds of kilometers per second, is an invisible cosmic killer, methodically tearing apart any chance the planet has for life. That's why building domed bases on Mars and sending people there in heavy spacesuits is almost pointless. You can bring oxygen, you can bring water, you can build sealed modules, but any atmosphere humans try to create artificially will leak into open space at the same relentless rate the planet's real, native atmosphere is leaking away right now. It's a fight against physics that humanity is currently losing. But engineers at the National Aeronautics and Space Administration have a plan that sounds like science fiction, yet is actually cold, hard engineering math. Build a colossal artificial magnetic shield in open space. Not on the planet's surface, not in its atmosphere, but far beyond it. A structure that works like an umbrella on an unimaginable scale, shielding an entire world from a deadly stream of solar radiation. To understand why this plan could actually work, we need to go back 4 billion years, to an era when Mars was a completely different world. It had a molten liquid iron core, just like modern Earth has today. That core slowly rotated inside the planet, and that rotation generated a powerful magnetic field, wrapping the entire planet in an invisible protective shell. The problem is, Mars is roughly 10 times less massive than Earth, and smaller planets cool down far faster than larger ones, the same way a small cup of coffee cools faster than a giant kettle. The Martian core gradually solidified, its rotation slowed, and the magnetic field began to fade. Within a few 100 million years, it vanished almost completely, leaving the planet fully exposed to the void. And that's when the slow execution of the Martian atmosphere began, stretched across billions of years. Without a magnetic shield, solar wind slams directly into the upper layers of the planet's air, with nothing standing in its way. Charged particles literally rip gas molecules off the planet's orbit and carry them into open space, particle by particle, second by second, without pause and without exception. The result of this billions-year bombardment is visible even now. Atmospheric pressure on the surface of modern Mars is 100 times lower than Earth's. At that pressure, water physically cannot stay liquid. It either freezes instantly into ice or evaporates almost immediately into the near vacuum, skipping the liquid phase entirely. A planet that once had flowing rivers and standing lakes turned into a dried-out frozen desert. But what if, instead of trying to restore a magnetic field inside the planet itself, which would mean remelting its core, something no current technology can do, we moved the protection far outside Mars, into open space, and shielded the planet from the outside, like a giant invisible screen? This is where a remarkable point in space comes into play, known as Lagrange point 1. It sits on a straight line between the Sun and Mars, where the gravitational pull of the star and the pull of the planet exactly cancel each other out. Any object placed at that point can remain essentially motionless relative to Mars, without spending fuel on constant orbit correction, hovering in the same spot indefinitely. That's exactly where engineers plan to deliver and deploy a giant space dipole, an enormously powerful artificial electromagnet powered by a compact nuclear energy source. This dipole has no equal among anything humanity has ever built in space before. It's not a communications satellite. It's not an orbital telescope. It's an engineering shield on a planetary scale, designed to single-handedly stand against the full force of a star. Once the dipole is running at full power, it will generate an artificial magnetic field of enormous strength around itself. That field will push the stream of solar wind aside, around Mars, the same way an icebreaker's bow pushes pack ice aside, carving a clear path through an otherwise impassable barrier. Behind the dipole, in the direction from the Sun toward Mars, a vast magnetic shadow will form. Inside that shadow, solar wind simply won't be able to reach the planet's atmosphere. The dipole's magnetic field will deflect charged particles long before they ever get close to Mars. The planet will end up fully wrapped inside an artificial magnetosphere, one created not by nature, but by engineering. The most striking part of these calculations is how economical they are. Stopping the atmospheric erosion of an entire planet doesn't require a structure the size of the planet itself. According to published engineering estimates, a single compact object weighing about 10 tons placed at the Lagrange point could deflect enough solar wind to completely halt the leak of Martian air into space. It almost sounds like a loophole in physics, too simple a solution for too massive a problem. But that's exactly the elegance of the Lagrange point. It amplifies the effect of a small object up to a planetary scale, turning a modest spacecraft, by cosmic standards, into the guardian of an entire world. Future engineers spend years calculating orbits down to 1/10 of a degree, just to balance gravity precisely at the Lagrange point and keep the dipole exactly where it needs to be. All you need is 1 second to hit subscribe on the Alaris channel. That way, you won't miss a single breakdown of humanity's most insane megastructures, the ones reshaping entire planets and everything we thought was even possible to build. And now, here's the most fascinating part. What happens to Mars itself once the shield finally locks into position and starts running at full power? The atmosphere stops leaking into space almost instantly on a geological timescale. But that's only the first step of a chain reaction that gradually engulfs the entire planet. Gases that spent billions of years building up in the Martian soil, in the polar caps, and in subsurface ice deposits begin slowly releasing into the atmosphere instead of dissolving into the void the way they did before. According to planetary scientists' calculations, noticeable changes in atmospheric pressure could happen in just a couple of decades, a blink of an eye compared to the billions of years it took to destroy the Martian atmosphere in the first place. Pressure will keep rising, layer by layer, year by year, with no need to ship air in from Earth. As pressure rises, the greenhouse effect intensifies too. Carbon dioxide accumulating in the atmosphere starts trapping more solar heat right at the planet's surface. The massive polar caps, made mostly of frozen carbon dioxide, begin to melt under that heat, releasing even more gas into the air. This kicks off what scientists call a self-sustaining chain reaction. More gas in the atmosphere means a stronger greenhouse effect. A stronger greenhouse effect means more heat. More heat means even more melting ice and even more gas being released. The process starts accelerating on its own, building like a snowball rolling down a mountain. Surface temperatures will rise slowly but steadily. Ice buried beneath the Martian soil for billions of years begins to thaw. And then, for the first time in billions of years, liquid water returns to Mars. First as thin streams, meltwater trickling between rocks, and then as actual rivers, flowing through channels that today look like dry, dead scars across the planet's surface. Once atmospheric pressure and temperature reach a sufficient level, people will no longer need heavy, sealed spacesuits with full life support systems, the kind that today look like miniature spacecraft. A lightweight breathing mask with an oxygen tank will be enough, roughly the same gear high-altitude mountain climbers use on Earth's tallest peaks today. Picture this for a second. A person walking through a Martian valley in an ordinary warm jacket, not a clunky spacesuit weighing dozens of kilograms. They breathe through a light mask, feel the wind on their face, hear the sound of their own footsteps on the red ground, and see, in the distance, a thin ribbon of water glinting under the light of a distant sun. The Magnetic Shield project isn't just an engineering solution for one colony or one mission. It isn't just a plan to make Mars a little more hospitable for future settlers. It's humanity's first truly serious step toward controlling entire planets, not just exploring them. We stop being a species that merely lands on other worlds and photographs the rocks. We become a species capable of reshaping the climate, the atmosphere, and the very nature of another planet by deliberate engineering design. Humanity's cradle is no longer just one place, and this colossal artificial magnetic shield, suspended at the point of balance between the Sun and Mars, could become the first brick in the foundation of a second home for our entire species. A home we won't stumble into by accident, but one we'll build deliberately, step by step, law of physics by law of physics.